Hey guys, what we're looking at here is the second formula, and we're going to treat this as a problem that we can either use our sheet here for, or we can use just one of the three equations. And I'm going to show you the way we do it with the three equations. So here's equation number 2 in kinematics. Okay, velocity initial times time plus half at squared. So this is displacement. So it's going to ask you like how far something goes, given initial velocity, an acceleration, and a time. Okay, so let's do it. Let's draw a picture. Initial velocity is 2 meters a second, let's say. The time is, let's say, 5 seconds. Acceleration is 2.5 meters per second squared. Okay, and let's find x. Okay, so what I've done is I've followed through. I drew the picture. I wrote my knowns. I wrote my unknown. X is what we're looking for. That would be like, how far does this ball go? So like, I may want to draw another picture here and possibly even draw like something like that to say, hey, how far does this thing go? Now this thing's accelerating. That means it's not constantly moving, it's speeding up. Okay, so let's figure it out. X, initial velocity times time, plus half at squared. So x is initial velocity, which we said is 2, times time, which we said is 5, plus half a, which we said is 2.5, and then t squared, okay, 5 squared. Okay, your calculator is going to want to jump ahead of you, so let's not let that happen. Let's do each step. Okay, how far it goes is 2 times 5, which is 10, plus 31.25. And these are in meters because we're looking at displacement. So this ball rolls a displacement of 10 plus 31, a positive 41.25 meters. Okay, and that was simple. We could actually find that on here. If we looked on this sheet here, okay, we'd find that this is a displacement formula. We have 2 of them. This is our original formula. It works. Now, if you if you're along the lines of just wanting to know 3 formulas, yeah, go for it. And then we'll solve now for initial velocity of something. Okay, still looking at formula number 2, where we say displacement is initial velocity times time plus half a times t squared. Okay, so let's solve for initial velocity. Okay, initial velocity is question mark. We know how far it goes. Okay, the x, we're going to say x is 10, let's say 100 meters. Okay, let's give it a time, okay, of 20 seconds, and let's give it an acceleration of 5 meters per second squared. So what we're looking for is initial velocity here. Now, here's a point where you can say, hey, you know what? Let me look and see on this sheet here. Can we get one for initial velocity that has true x, t, and a? Let's see. Initial velocity here. It's an initial velocity formula. X, t, and a. So I could just plug my numbers into here, but again, if you're along the formulas, you can write the formula down and you can plug and chug now. So x is 100. Initial velocity, we don't know what it is. Time is 20. Okay, half. A we'll say is 5. And t squared is 20 squared. I left the units out so that way it's more simple to understand when you're doing just the math. Our answer is going to be in meters per second, so we know that. So let's clean this up a little bit. 100 is, let's say, 20 times v naught, or initial velocity, and then half. Okay, so let's do this in the calculator. So I would say, so that's half is 0.5 times 5 times 20 squared. Well, 20 squared is this. So this side of the equation is about 1,000 here. Okay. So look what we got here. We got 1,000 attached by addition. So let's subtract that on that side. Makes it disappear on that side, but what I got on this side is negative 900 equals 20 v naught. Okay, so divide through by 20 by 20. Okay, 900 over 20 is okay, this is an interesting one. Now, I put a time of 20 seconds here. Okay, I said the acceleration was 5 meters a second, and I came up with a negative number. Now, very interestingly, this is saying that the ball was actually had a velocity, or had to have had a velocity in this direction, which is kind of interesting. So 45 meters per second this way, and then something gave it an acceleration to the right. Okay, so, and this is kind of a nice little intro to gravity too. But this had an initial velocity. So initially, this ball was traveling negative 45 meters per second. Something started to accelerate it positively, which changed it to a positive velocity. So keep in mind your signs. This ball started out rolling negative, and then something sped it up. Now, what I'm gonna say is that this is a perfect example of something like this, where the ball is like started to go here, and we'll say it rolled negatively, which is in this direction. So if it started here, the hill actually slowed it down and then sped it up as it went over the hill. So this could be a situation where the ball is going backwards over a hill. But anyway, that's how you solve for initial velocity. Okay, again, looking at that second formula, x is v naught t plus half a t squared. We went ahead, we solved for this, we solved for this. Guys, in this one, we're not going to solve for t because it's very difficult. It's a calculus type thing. But we are going to solve for a. Okay, so now, again, if you want to go and look for a, given x, VO, and t, x, VO, and t, okay, here it is, x, VO, and t, you can solve it with this one, okay, this one here. Okay, and I will say that, yeah, something about it's nice. I mean, there's a lot of formulas here, but if you want to stick it to just 3 of them, this is number 2. So let's solve for a. X, let's say this ball rolls an x distance of 20 meters. Let's say the initial velocity is 0, starts from rest. Let's say the time that it takes for all this to happen is 5 seconds. We are looking for a. Okay, so Again, you can go to your sheet here and find A. Here's the acceleration formulas. I'd stick with this one. Or you can just put this one down. X is VOT plus half AT squared. Okay, let's figure it out using this formula. X is 20. Initial velocity is 0. Time is 5. Plus half. A is what we're looking for. And 5 is the time, but we got to square it. Don't forget to square it. Now look at this. Initial velocity times time is 0. So this makes it a little bit easier. 20 is half A, half times A, times, we know that 5 squared is 25. You're not squaring the whole thing, just the 5. So half times A times 25. Well, I know that half times 25 is 12.5 if I multiply these two numbers out. So what I've got left is 20 is 12.5A. Get A by itself. Okay, and I'm going to come up with 20 over 12.5. Turn that on. Okay, 1.6. And I know my units for meter acceleration are meters per second squared. So the acceleration of this thing is 1.6 meters per second squared. Okay, so it is accelerating. Again, we're not going to solve for t in this one. Unless the initial velocity is 0, t can be solved. And I'm going to do one of those for you guys. Okay, so again, looking at our second equation, x is v naught t plus half at squared. We're going to give the initial velocity a 0 value. We're going to solve for time. Okay, so let's look over at our sheet here. Could we use this sheet? Yes, we could. I got a couple of them here. T is VF minus V over A. I don't have a VF here. That won't work. I've got this one here. Okay, and I've got this one here. So you'll see that I'm going to stick with this original equation number 2. I'm going to give you a situation where we need to solve for t. Okay, so how long does it take for a ball to roll 20 meters? Initial velocity 0. And then acceleration of, let's say it accelerates at 5 meters a second squared. Okay, we're looking for time in this equation. So I've identified the knowns and the unknowns. So choose a formula. Okay, there's our chosen formula. We know x is 20. So let's plug that in. Initial velocity is 0. Time is question mark plus half. A we have as 5. And then t squared. Okay, let's clean this up a little bit. 20. 0 times anything is 0. Half times 5. T squared. Okay, half times 5 is 2.5. So let's go 20 is 2.5 t squared. Okay, order of operations tells you that you've got to get rid of the 2.5 by division because it's multiplied. And I'll just do that in the calculator. 20 over 2.5. 8 equals t squared. Almost there, guys. I promise. T squared is 8. So to get rid of the square, we square root it. So square root of 8. .8 seconds. So for the ball to go from here to here, 20 meters, with an acceleration of this and then the x distance here, it will take 2.8 seconds. Now you may find it easier to go to your cards and solve for time. Now all of these formulas that I've got here for you are literally just those three formulas put into a comprehensive list. Like I said, you may find it easier to do it like that or to do it using just the three. It's up to you.